Okay, let's continue. So now we're going to look at the second collision resolution strategy, which is closed hashing. Okay, so in open hashing, we said that in order to insert a key, all the keys that collide to the same slot in the hash table are mapped in one or they form one linked list. In closed hashing, we are not going to form a new linked list. However, we are going to store everything inside the table itself. And we use that using what we call a probing sequence. So let's see how closed hashing works as a picture in order to get a feel of how collision is handled in closed hashing. So let's assume that we have a hash table in the following setup. So we have this hash table. Some of the entries in this hash table are full. Some of them are not full. Okay, are empty, and we want to insert the element with the key 63 inside this hash table. Now, how do we do that? So let's say that the hash function tells us. Let's say that the hash function tells us that we have to insert the element right here. Okay, so the hash function is telling us insert the element here. However, as you can see, this place in the hash table is already full, so we cannot insert the element here. So what happens then is that we are going. There is something called the probing sequence. The probing sequence is going to tell us try this slot, then try this, then try this, then try this. So there is a sequence which is called the probing sequence, which is going to tell us the slots where we have to insert the key one by one. So in this case, the first item in the probing sequence is actually the result of the hash function. So this first item is h of 63. This is the hash function of closed hashing. It uses a probing sequence as well. This is the key of the hash function, and this is the step number of the probing sequence. The first step number in this case is 0. Okay. More precisely, how it works is we have key and step number equals the hash function plus a function of the step number. So what happens in this case is the first item in the probing sequence is or the first step number, or the initial step number of the probing sequence here is 0. So the hash function of closed hashing is going to be this hash function plus a function of 0. Okay, of j. This one will always return the value of the hash function itself, which means return the value of the hash function itself, which means f of 0 is going to be 0. So this hash function is telling us that we should go to this place. I mean, don't try to understand why this place, because this is just an example. Okay, it could have been another place. Here we are just trying to see the probing sequence in execution. When we are not trying to give a definition of a particular probing sequence. All we want to see the probing sequence in execution in front of us. Okay, so again, this is the function of the probing sequence of the closed hashing. Which part of it is the hash function, and another part of it is a function of the step number of the probing sequence. So this is first telling us that we should go here, and this is actually h of 63. And then we find that there is a collision, so we have to choose another place in the hash table. How do we choose another place? Again, it's according to the probe sequence. The probe sequence now is sending us right here. Again, there is an item in this slot, so we are going to ask the probe sequence again. Please send us somewhere else. So the probing sequence now is sending us over here under 95, and the 95 was null, so we are finally able to insert in this slot. Okay, so as a summary, if I want to insert in a hash table, I compute h of k. If the slot in the hash table is already occupied, then I have to move to another slot. Which slot do I move to? This is dictated by the probing sequence. It can be this one or another one, etc. Different probing sequences are going to give me obviously different trials of slots when I do insertion. So this is how insertion works in a closed enclosed hashing. I use a hash function and then I follow the probe sequence. I keep following until I find an empty slot or until I find out that the whole table is full and I cannot perform a new insertion. So this is what is probing. So this is the essence of closed hashing. So in open hashing, when I see a collision, I add an element to the linked list. In closed hashing, when I see a collision, I jump to another slot in the hash table, and I keep jumping until I find the slot or until I know the table is full. This is why it's called closed. The other one is open, this one is closed, because we don't open the hash table with anything. The hash table stays the hash table, okay? We don't open it, so it's closed hashing. That's a way of remembering what it is, so that you don't get confused. Now, we have talked about how we insert. Now, how do we look up an element in the closed hash table? We are also going to follow the probing sequence. Okay, so in order to look up an element, we are going to ask the hash function send us to the slot in the hash table where I can in the hash table where I can send us to the slot in the hash table where basically the index where the item was inserted. And if the hash function finds out that the slot is already occupied, then we ask the probing sequence to send us to the next slot, and we keep asking until we find the item or until we have gone through the whole table without finding it, in which case the item is not there. So this is how lookup works. Now in delete, we are going first to do the lookup. So use the hash function, find the first slot. If it's not the item we want to delete, then follow the probing sequence until we find the item or until we have reached either an empty slot or the whole table is full. Okay. Now let's say I want to delete number 12. How do I delete the key 12? So I search for 12 first, and then I find it. How do I delete it? Can I just delete it like that? Now the problem with deleting it just like that is it might be part of a probing sequence of another number. For example, assume that in order to insert the number 95, the hash function sends us here, and then sends us here, and then sends us here. So In order to insert 95, this is insert 95, the hash function first sends us here, and then the probing sequence tells us to go here, and then tells us to go here. If I delete 12, what happens? If I want then, after deleting 12, if I want to search for 95, I will go here with the hash function, and then with the probing sequence, I'm going to go here, and then there is an empty slot. What does that mean? It means 95 is not in the table, right? But this is wrong, because 95 is actually in the table. So I have broken the probing sequence for the item 95. So instead of deleting the item, what I'm going to do, I'm going to mark it as ghost. Okay? Now, what does ghost mean? Okay, it's either it should be a value which is not null and which is not equal to any of the keys in the table. For example, if all your keys are positive, use -1 to denote the ghost cell. Now, what does that mean? Now, if I'm searching for 95, I go through this. I don't find it because it's occupied. I go through this. It's a ghost, so that means the item I'm looking for might be somewhere else because this is a deletion. So I keep looking until I find 95. So having this ghost is going to help me basically maintain the sequences or the probing sequences for my keys. If I make it null, I may not be able to find sequences or the probing sequences for my keys. If I make it null, I may not be able to find certain keys, although they are still in the table because I have broken the sequence. But if I put it as ghost, now I'm still able to search for the keys. So now lookup is going to change. Instead of saying I'm going to look up the element until I find an empty slot or the table is full, now I'm going to say I will keep looking up. If I find an occupied slot, I keep looking. If I find a ghost slot, I will keep looking as well. Okay, so this is how lookup is going to change. Insertion is going to change as well. So I'm going to insert as follows. If the slot is occupied, I am going to insert. If the slot is empty or if the slot is ghost, I am going to insert. It's fine. It's fine to insert in a ghost because it does not affect delete and it does not affect lookup. Because in lookup we said if the slot is occupied or ghost, I'm going to move on. When insertion uses ghost for insertion, then in lookup, instead of looking up a ghost cell, I'm going to look up a cell which is occupied. So it is not affecting the semantics of the insertion of the lookup. Okay? So again, a summary of the operation. In order to insert, I use the hash function. The hash function sends me to a slot. If the slot is occupied, I move to another slot according to the probing sequence. And as long as I see an occupied slot, I keep moving. I stop moving and do insertion when I meet an empty slot or when I meet a ghost slot. For lookup, I go to the slot where the hash function sends me, and if it's occupied, I keep moving through the probing sequence until I find either an empty slot or a ghost slot. For delete, I go to the slot indicated by the hash function, and I keep moving through the probing sequence until I find If I find an empty slot, it means that the item I'm trying to delete is not there. If I find a ghost slot, it means it might be there, so I keep looking for the item. If I find the item, I'm going to mark it as ghost. So this is how we perform the three operations in closed hashing. In terms of complexities, all we can say is that if we have a good hash function, then we have an expected complexity of big O of 1. However, there are no guarantees for the worst case complexity. There are no guarantees that the worst case complexity is going to be big O of 1 or anywhere near it. Because as you can see, I can follow the probing sequence so many times. In fact, if the probing sequence can go through all the table, I have to go through all of it for lookup. And if the item is not there, if the table is full, I'm looking for an item through the probing sequence, and I don't find it, I actually have spent big O of m time trying just to look up an item. So in the worst case is bad. However, because of things we will see, how we are going to deal with that, this worst case, we're not going to see the worst case. However, it happens, okay? But we don't see it much of the time. On average, we have an expected complexity of big O of 1. Remember, hash tables are not used for their guaranteed performance in the worst case. So now, we understand open hashing. We understand how we do the operations and their complexities. And the other way of dealing with collision is closed hashing. We understand how to do the operations and their complexities. Okay. Now, next we need to talk about probing. Okay. So far we have talked about probing as a general sequence. However, we need to implement it somehow. So now we are going to look at probing. These are explanation of the different things I was saying in the slides. The three dictionary operations. So probing, we said probing is the mechanism by which we navigate through the slots in the table, trying to find the slots that we want. Either we want to insert into, or we want to find the key, or the slot where we want to delete a key. Okay, and we said probing is a sequence that can send you anywhere. Now there are common probing techniques. One of them is called linear probing. So in linear probing, what happens is in linear probing, what we have is if the hash function sends me here, then the next item to probe is this one, and the next item to probe is the next one, the next item is this, and this, and this, and so on. Or it can also mean something like that. The hash function sends me here, the next item to probe is this, and then the next is this, and then the next is this, and so on. In both cases, the step that we take from one slot to the next is always the same. So here, if this is like slot 1, this is 3, 5, 7. In the previous one, it's 1, 2, 3, 4. It's like a geometric. It's like an arithmetic series. Okay, it's linear. Okay, 1, 2, 3, 1, 3, 5, 1, 4, 7, 10. You know, it's linear. This is called linear probing. So linear probing can be captured by this equation. This is this is the term that we have seen in the previous slide when we said H63 0, which was the first attempt to do insertion, and then we had H63 1, which was the second attempt to perform insertion. right? So how do we compute the probing sequence? So this is that. This is the key. This is the step number of the sequence. It equals